That's fine. Hi guys, good morning. Everybody okay? Does everybody has coffee, tea, right? Leave a little nicer. Welcome back to some workshop that I call Data Science Onboarding on Ibex. Tea is good for this time of the morning. Okay, so given that you were on time, let's start, okay? Well, first of all, who am I? My name, for those that you don't know, maybe I'm called the data science guy in the campus, maybe I'm the Conda wizard, I don't know. But my real name is Didier Barras Bautista. I am part of the KAUST Visualization Core Lab. This is my team. We have different expertise, for example, in VR, HPC visualization on different HPC clusters that we have here. And we have two data scientists. One of them is me. And you can see my fat face there. Okay? So, first, I'm going to start with a lot of information because usually my colleagues from the KSL start with the other way around. But raise your hand if you find this website. As a matter of fact, please open your browser and go to this website, wiki.biz.kaust.edu.sa. Okay, everybody is on that page. So you can find there in the bar in the right, Data Science Tools User Guides. So I created this web page exactly for this kind of situation where you are just joining KAUST and you don't know where to find information. So in there you have an actual section called Ibex Starting Pack. Now what I want you to do now is to click in those links that you have there so you understand that, for example, when you join here at KAUST, you have access to Ibex, but you don't have complete access to Ibex. There's a link there that says severely constrained that will lead you to the part of the documentation that will explain that you have to be attached or added to a group of your PI. Okay? And that's a constraint because we have many people coming and we have to have control over the users. So there is that. The most important link actually is there that says myibex.kaust.edu.sa. Okay? So if you're new here and you haven't attached yourself to a group in your PIs under your PI management list, please click that one, fill the form there, and send an email to your PI and say like, hey, boss, we need this permission to happen. If I'm going to use Ibex, I need it, okay? So talk to your PI, don't be afraid of them. Usually they don't bite. But that's one of the key links there, okay? So you will activate yourself under the Ibex list that allows you to use the complete Ibex cluster. All right? Also, you have some storage tips that I put there in yellow, for example. Those are going to be recurring in this workshop because those partitions are the usual suspect that people doesn't know how to find. You have several other links. For example, last week, Ibex 101 happened. There is a link for that there. I mean, I put all the useful links that I can think of, but if you have another link that you might need, let me know so I can include it there because this is something that I want for everybody to basically share and know, okay? Especially for the newcomers. Now that you know this, please tell your friends, family, and PIs about this webpage, okay? So that's one of the sources of information here, right? This webpage. Now, we have the actual documentation for Ibex that you might know, or if you don't know, don't worry, I will show you. This documentation talks ibex.hpc.kaust.edu.sa is that contains all the information about Ibex and Shaheen. So for those that you don't know, Shaheen is a different type of HPC cluster. We have that's our flagship supercomputer. But we have an internal supercomputer for you guys to use, which is called Ibex. So we have all the documentation put into this web page, and you can search everything that you need on this corner over here. You just open it, type some kind of text that you are looking for, and there will be then the information for you. Okay? So far, very clear, right? 2 websites, all the information that you need that you have to read. If you read all the documentation here, you're way ahead of many people that just jumping into KAUST and try to do data science or what have you in Ibex. Okay? And I know a lot of them. But anyway. So the next stop in the information train, the Slack channel. I know it's not a fancy social media. It's not probably something that you heard from. It's not TikTok. This is a professional, quote unquote, professional way of chat with us. This is a fast lane to 2 things. 1, access to us. I'm usually lurking around for the message in the channel called General. But the other one is the extension channel. The extension channel will be important for you once you launch a job in the Ibex cluster and you say, like, oh, I missed the time. I need more time, just a little bit more. That's the extension channel for you. You can see an example there. Like all these users, they mismanage the time. Usually they don't put enough time and they need just an extra time for their job to finish, for the execution to happen. So that's the channel that you need. This is very direct. You don't need to raise a ticket or whatever. Also, if you have a very quick question, you can throw it in the general channel, like, hey, why is Ibex not allowing me to enter? Something like that can be very easily answered in this particular social media, okay? Also, it allows you to format the text into a code, so it's easy. We can share also scripts and so on and so forth. That is going to be very useful because it makes things clear, okay? So about that, communicating with us. I have to put this slide here. How do you write a ticket? Okay? Why I'm saying this? Because I should tell you, you have at least master's degree, correct? Okay, can you hear me? Let me figure out how is this, but usually should be different. This is a new battery, supposedly. Okay. Testing. Ah, that's better. So, like I was saying, there is a problem for me. So when people actually write to us using that email, if you have a problem, usually you use this email, ibex@hpc.edu.sa. The problem is like, usually you write like, hey, I have a problem. And that's it. I have seen many users just like, I don't know what's happening, something's wrong. And it's like, yeah, sure. So I have a giraffe. Something like that. Like, I'm very tempted to respond like, sure, I mean, sad, you have a problem. Then what? So in order to write an effective ticket and avoid us to just ping pong with you, write us who you are, where you're working, and what did you try? Append your scripts. Tell us what's wrong. Because literally it's like, I cannot enter Ibex. Like, okay, so what's the error in your screen? It's like, do some minimal sharing of information with us, guys. If you don't do that, I will actually share with you this. These long list of things, step by step. I will personally answer, okay, give me your login name. The next email will be, what cluster were you on? So it will be about 6 or 7 emails just because I know that you're not sharing with me any information that I can help you with. Okay? So try to put, information in the ticket when you're asking for help. When you have something that is really, really heavy to implement on Ibex, that's what we need to know. Like, hey, can you install this for us? And like, okay, but let me know which one of the different versions of the software do you want? The page, the instruction page. Give us more details. Because, guys, we're not experts in every software in the planet, okay? Many people come like from the informatics field. It's like, hey, can you implement this in Ibex? It's like, but I don't know what the software does. What it's supposed to do. How I'm supposed to actually install it. So those details matter. It's faster for you to get a result and faster for us to work, okay? So next step. So the next step is something that is called a GitHub repository, okay? This is our material for today. The GitHub repository is, well, raise your hand. Do you know what GitHub is? 1, 2, okay. Couple of persons. So for those of you that don't know what GitHub is, thinking as a sort of library of codes. As scientists that wants their science reproducible, usually share the codes through GitHub, so you can then just copy paste it in your computer and probably run it if it's correctly written. This one in particular is from us. And this one in particular has all the streamlined things that we can actually give you. You don't have to write anything. You just have to execute them usually, okay? So we will have you have actually the link in the first website that we were visiting at the beginning, the BizLab wiki page. So taking into account that there is also different GitHub repositories for the KRCCL that allows you to install stuff or try new stuff or more advanced stuff, okay? Finally, so click and subscribe to our YouTube channel. If you don't know, we have a YouTube channel. We, the KVL, have produced several videos that are mini tutorials that you can check. Even this one is being recorded to be put on that channel, okay? So we have, for different examples, you have tutorials from different technology that we have there. The Aviso, for example. We have the artificial intelligence hands-on in Arabic too. So for your friends that speak Arabic, we have even some material there. We have how to deploy your favorite UIs. And more importantly, on the bottom, you can see the tutorial for those of you that are Windows users and refuse to work in Linux like a pro. So you have there how to set up your Windows machine with all the tools for data science that you might need now and in the future. Well, that's how we sell it. Anyway. So we're going to have a little break now, just because I saw some of you coming. So get your fill of caffeine with tea or coffee. And we will start in a couple of minutes, okay? Also, I will have to deal with this. Okay, so ready? One question for you guys. Which one of you took Ibex 101 last week? A couple of you. Okay, good. So that makes my job easier because then I don't have to explain you, but if you see any of your peers confused, please explain. But anyway, so let's start with what is Ibex. So Ibex, in my time when I was young, we used to call this kind of clusters Beowulf clusters. What it means is a Frankenstein. So it's not uniform, it's not homogeneous. We have actually different parts from different vendors, meaning that you have different parts where you can play, okay? One important part that I want to be sure you understand that this is not your personal computer. You cannot install things as you would install in your computer. And it has different parts where you should install the things that you want to work with, okay? So we have Intel nodes, GPU nodes, AMD nodes, large memory nodes, and so on and so forth. My colleagues on Ibex 101 explained thoroughly, probably, what that means. But just in a nutshell, we have a Frankenstein. This is our baby, our bed test for different new technologies, okay? So, as a matter of fact, if you don't know, and you will find it in the documentation, we have different types of CPUs. Like I mentioned, we have some that are very special, that are the large memory nodes. We don't have many, but we have them. And those are very useful for when you have to run something that is memory bound, and you need a lot of memory, okay? And then we have several other nodes with up to 40 CPUs per node. Already 40 CPUs per node is really remarkable, really big. Okay, so this is the golden part of the HPC cluster. We have different GPUs. So if you are aware of this, the GPUs now are like the tool to have if you want to do data science. Well, not exactly, but you know, deep learning and training models and LLMs and all the hype that is being going on. Like, for example, DeepSeek lately in the news. So if you know something about this and you've been a gamer as long as I've been alive, like me, you can see that those in the top row are very old GPUs. Those ones are actually the first GPUs I had access when I arrived here. And then you have the GTX Titans, the B100s, and the A100s. Take this as a history of how the technology has evolved, because at the beginning, GPUs were for gaming, and now when you go all the way to the Ampere, those are specifically for processing data, okay? That's the difference. You can play around and try to get a hold of those, but bear in mind that GPUs are very demanded, so you will have to fight for them, probably, or wait a long, long time. Okay, but an important concept that my colleagues in Ibex 101 must have also mentioned is that you have basically two parts where you can work. One is the home partition, and the other one is the Weka partition, or a scratch partition in some cases. Okay, so home is where you land in the gateway of accessing Ibex. It's very small, is probably worse than the machine that you currently have, unless you have a machine from 2012. This home partition is very bad as a computer. It's just meant to have some scripts there. It's meant for you to enter the supercomputer, but it's not the supercomputer. It's actually bad to have things passing through there because it just slows down your computing process. On the other hand, your playground, your true playground, is the Weka I/O. Okay, there you have 1.5 terabyte each of you, or the scratch. Okay, these are the storage partitions that you are going to have to play with. You can install things there, have it in there. Now, one drawback: there is no backup for that partition. Okay, whatever you have in that partition in Scratch or Weka is not being backed up by any of the team. So it's under your responsibility to not lose the information you put there. if you have something really, really important that you have already finished computing, do a backup somewhere. Because if something happened to Ibex for whatever reason, and it erases the data, we cannot get it back for you. All right? So just take that in mind. All right, so there is a third one, which is basically a storage unit that appears to be virtual while you are running some jobs. We will see how that works later. But just for you to know that it exists for when you're generating data that is interim and you don't actually care to get it back, not your final data. And it can be basically discarded or, well, it will be lost at some point. Okay, so I know you probably saw this image in Ibex 101, and if it's not, if you didn't take that one, you should know that this is a schematic of a HPC cluster. You will enter using your computer in the part that says terminal there, and you will land in something called the login node, okay? That's not the supercomputer. That's just the gateway. So the supercomputer is actually made of the parallel system that you see in blue there and the compute nodes that you see in green. That's the supercomputer. Those are connected by actually technology that is very fast, and that's the idea of a supercomputer. The problem is, like many beginners, they only know the computers, and it's like, okay, the login node is where I should do my work in the home directory. And it's like, no. That's not it. That's not the case. That's only the door. And why I'm mentioning this? Because the login node is always under attack by new users. So, like I told you, the home directory is not fast. The login node is not fast. It's slower than what you have currently now in your desk. Okay? What you see here is the memory of the whole login node taken by one user that had the brilliant idea of running Mathematica on the login node. What makes that a hassle for all of you, because none of the users of Ibex could access Ibex, work on Ibex, literally write anything on Ibex, in their partitions or not. Okay? If you see this behavior, say something, send an email, tell us in Slack, hey guys, you know, it's like this is awfully slow. What's going on? And we can check. Okay? So you will see when you enter the machine that you have something that is at login something, one number. You know that you're working in the login node when you're there. The compute node does not have login node, and you will see it. So the login node is tied to the home user space. Okay? Remember, this is just a very slow, very small machine that is just allowing you to do some work, but it's not meant to deploy something really big. All right? Especially, do not store datasets here. Okay, so let's start with the exercise. Please log in into Ibex in this way. We're going to be using the G login node. As you can see in this slide, we have 3 different login nodes for 2 reasons. Actually, we have a login node specifically for software that runs in CPU, software that runs in GPUs, and because it is very popular, one specific node for VS Code. We will talk about VS Code later, but please use the G login node to enter Ibex, because we're going to use pretty much scripts that brings the material from there. Okay? So for those of you that use Linux, thank you. Well done, pros. Open your terminal and enter the SSH command. For those of Mac, okay, kind of you have some respect from me. The same, a terminal, use SSH. Those of you that like Windows for some reason, please download specifically MOBA Xterm, okay? That's the easier way you can download, that's the easier software that you can download and you can deploy it, okay? So let's do that. That's exercise 1. All right, everybody log in? Raise your hand if you already log in. Okay, nice. Okay, now you are in the login node, correct? Everybody has that add login something in their screen. So please start typing who am I? Start typing these commands, as a matter of fact. If you type who am I and you have an identity crisis, then you find yourself. Okay? That's your user. If you type PYD, print working directory, you will see that you are /home your user. Am I correct or I'm just wrong? What do you say? Yes? Okay. Now, for example, I would like you to do cat for concatenation /etc/red hat -release. Okay? Tell me, what do you see? What do you see? You haven't logged in successfully. My colleague here, Tiziana Ricardelli, is going to help you if you have some problem. She will be so kind to do it. Okay? So what do you see when you do cat? Okay, that's the operating system of Ibex. Okay? More to the thing. Type module AV. That's short for module available. So you have there deploy a super long list of the software that is basically installed on Ibex. Okay, everybody with me to this in this point? Yes. Okay. So if you type module list, it should come back with an empty thing because you haven't loaded any module. Okay. But now I want you to do module AV or module available M. Okay, with module available M, what do you see? Machine learning module, for example, MATLAB, whatever it is, Megalodon, yeah? Exactly. So that is basically a very quick search or the modules that is installed on Ibex that start with the letter M. All right? So that's a very quick way to just search through Ibex to see what's already there and available to you. Okay? As a matter of fact, do module AV again and go all the way to the bottom. I want you to see something that is called a stack. It's all the way down. Am I right? There should be a CPU stack and a GPU stack, right? Something that's a RL9 something stack. So that one is actually a shortcut that will allow you to enter the other part of Ibex, meaning that if you do module load RL9 CPU stack, it will import all the software that is installed on the CPU side of Ibex. Okay, that's a shortcut. You will see it in action in a minute, but the thing is like, Ibex is separated between CPUs and GPUs. The programs are not the same in each side. If you want to use something from the CPU side or the GPU side, depending on your login in your login node, that's the model you have to load to call that. That's what I mean. Okay? So far, so good? Very easy, right? Okay. So raise your hand if you know what's bash/shell. 1, 2, 3, 4. Okay, most of you know. So in order to do something effective in any cluster, as a matter of fact, you might not know it, but the world runs on Linux, meaning that the way you interact with a machine is through bash/shell. If you don't know what to do with bash shell, in our videos, in our YouTube channel, like and subscribe, we have actually a tutorial about how to use bash and shell. Okay? It's really powerful, it's really easy, it's super, super, super good to know. So I think, it's my opinion, that these are the most used commands from bash shell inside of the cluster, because it's technically just change directory. Okay, where do I want to go? I want to go to Ibex/user $user, which is my partition. Or I want to get out, change directory ... Then list all the things minus LTR. So give me a list sorted by time in reverse, right? Stuff like that is really, really easy for all of you that already know certain parts of Linux. Okay? So, as a matter of fact, if you can, the only thing that I want you to try right now is to go into Ibex/user $user. Because I want to know which one of you have Weka and which one of you have the other partition. So let me know if you have like permission denied when you try cd/ibex/user $user. The one in the middle on the top. You okay? You didn't find it? Not such found. Not such found. Okay. Then try the second one. /ibex/scratch/user. No. The question was, can we have both? No. So the thing is, like, those that have /ibex/user $user, you are on the Weka storage system, which is a newer storage system that we have. Some other users use the /scratch ibex/user, which is something that we refer as BGFS. That's the technology. It's a different storage unit, but they are both connected to Ibex. Okay. It shouldn't be possible, but that means that you don't have any of those. Odd. So you didn't find any of those. Really? That's interesting. Well, anyway, don't despair. If you don't have the Weka, we're going to use the Scratch for your examples, okay? It's the same thing, just different type of technology that right now is not very, very important for you to differentiate. Okay? So you have the first one at the end. Okay, good. I'm afraid that we have one that doesn't have any. Yeah, typos are your best enemy. By the way, another thing that you might not know, but also spaces are your worst enemy. So use underscore when you're doing something, like creating new files with underscore inside Linux. Inside Linux is better than just white space. Okay. So that's pretty much, what's the question? Mm-hmm. Okay, so the question is, what's the difference between CPU nodes and GPU nodes, and what's the difference, right? So if you remember, we have a Frankenstein. So what happens is that there are some people in the university that doesn't use at all GPUs. So what was decided was to have these partitions and install things that are GPU dependent on the G login. And the other programs that are only CPU bound, that they need CPUs and they cannot work with the GPUs, they are in the CPU login node. Okay, that's basically a logistic decision, like things that work in one of the other ways. Now, your question is good because it's like, why do we have a third login node, which is the VS Code login node? So VS Code is a very popular GUI used by many in the university, but at the beginning, when we were allowing the connection from VS Code to the G login node or the CPU login node, it filled all the storage files with a lot of different JSON files. So it was jamming all the traffic. So the system administration decided to do a third login node that cleans that on the regular. Because we still have some users that come and just connect with the VS Code to the G login node, and it fills all the temporary files, all the storage that we have there, and jams the whole login node. So that's why we have 3 different login nodes. But the difference between the first 2 and VS Code is that also that the software installed is basically a replica of the CPU nodes. Okay, but and why we're actually logging right now in the G login node is because some of the examples that we're going to run from the data science onboarding repository are going to require a GPU, especially the last part where there is containers to do deep learning. Okay, so all right, talking about enemies. So when you arrive to an HPC center, just like it happened to me, I didn't know what was a Slurm. A Slurm is a special scheduler job manager. While it's very complicated to say it, technically speaking, it's like, imagine that you are the supercomputer and then you have this room full of people and you have to give one part of the supercomputer to you. So you have to do that in an ordered way, and probably from this side, they are asking for a specific GPU, and this side doesn't care. That's Slurm. That's basically a way to communicate with the HPC cluster and tell him like, hey, I need something from you for this amount of time, and so on and so forth. It has several details, but it's usually something that is is technically used in all the HPC. There are a couple of different systems. But for example, now that you are there inside, you can do, for example, sinfo, and the S comes from because it's Slurm. Okay? So why don't you try to type, for example, ginfo, which is an in-house, just ginfo, not minus D, just ginfo. Ginfo is an in-house tool developed here. And now you should see a list of all the GPUs that are working right now on Ibex. Right? You have different columns. You have active, you have idle. If you just type ginfo, that's all that you need. Why do you need this kind of information? Because you might need specifically to access one GPU because the other are basically always working. Okay? Or it will give you an estimate of how long do you have to wait. Now, try to do sinfo minus p all format these things, 16n, 12t, 12c. That's challenging, but I like that one. So for you, my friend, connect to Ibex. We're already in the login node. Yeah, we have Unify. Okay, did you deploy the sinfo? So sinfo will give you the information of all the nodes in Ibex. Who is working, who is idle, who's not. CPUs, last memory nodes, GPUs, and so on and so forth. Okay, it's a long list. Now, one that is very curious is SQ, and you will find this, that you're going to be using this like on the regular. Just type SQ. And with SQ, it should deploy like a freaking long list of everything that is going on right now in Ibex. Like things that are working, like heavily. And as a matter of fact, it will not be, you will not see the complete list from the start. It's like really, really, really long. So SQ is very useful, especially when you use some flags. The flags can be -u, -p, -j, depending. Something that I like to remember everybody is like, you're always wondering, when is my job going to start? You can use that one, SQ -u, your username, -- start. It will give you an approximate of when it's going to start. Now, I should tell you also, that's a trick, because it's just a bad guesstimate of when your job is going to start, but at least you have a peace of mind that, okay, I have like 3 hours to waste. I can write my thesis now, or something like that. But okay. So, moving on. Slurm has 2 modes, literally. One is called batch mode, and the other one is called interactive. So the batch mode is something that you basically write a love letter to Slurm and say, please, the roses are red, give me back my GPU and for this amount of time. And then the interactive one is more like, I need to debug something right now, and I don't need that much of my computer, my supercomputer. I just need something to get in, check this script, and get out. The interactive session, technically speaking, is just for you to use about 3 hours, 6 hours, 8 hours, but not 24 hours. Because the interactive session disconnects when your terminal is done. When you click close, the job is gone, usually. Okay? So the interactive session is just a short thing, a short stint. So for example, let's play with that. Let's start with the interactive mode. Try to write the first command. This is srun for that time, 10 minutes. You're asking for a partition equals batch. Then --pty, that's a pseudo terminal. And then you are executing bash and logging in. That's what it says in the first line. Okay? Try to do that now. srun by 10 minutes in the partition called batch, which is the actual working partition of Ibex. And then --pty /bin/bash -l. Now, by the way, if you were in Ibex 101, my colleagues had a partition. You're working as normal. This is the normal held through Ibex. Okay, you have it? Excellent. You have it? Okay, so you should notice that alongside your username, now there is no logging. There is something that is CN of compute node, or a GPU and a number. Am I correct? All right? Perfect. So let me know, just raise your hand if you could do this. Ready? Okay, fine. We still have half of you are still waiting. Or you have already done the allocation? Done? Good. Okay. So you can get out of that just by typing exit and enter, and it stops. Okay? Now, we're going to use another command to do interactive sessions that is called salloc. So please try these two, salloc --time, 10 minutes, --partition, very easy. And then try salloc --time partition batch. Yeah, why not? 1 GPU, and then memory and CPUs per task. Just 10 minutes, so it will be very easy to get your hands on that. Yes? The default should be batch, but I like the partition to be specified because we have a debug partition. that is also meant to be working really fast. The time is only 1 hour, but I could not put all of you in the same partition, in the debug partition. It will be very slow because it's just like accepting very few users. So at the end, it's better to use the partition, if, in this case, for these exercises. Okay, everybody did this 2 SLOCs? Raise your hand if you completed, or when you complete that. Okay, nice. So for those of you that completed, please go to the next part. Use SSQ minus U user. Okay, if you were able to do the SLOC, so do you see your work? Do you see your queue? Okay, that's an interactive session that will be running all the time. Now, how do you stop these things? You just type scancel, the number of your job. The first column that you see, you can put it there. So try to cancel your jobs. So easy peasy, right? You were able to get in, you got the partition, you got the resources, and then you kill it with scancel. Good? All right, so far, questions over here? All clear? Yes. Uh-huh. Mm. The natural question. Can I modify my job before it starts? My code before the job starts, right? Yeah. Very good question, because everybody wonders the same when you're working with this. So as long as your job is in interactive mode and your code is changed, so let me start over. If you modify your code before the SRun starts, the interactive job starts, the modification will take place. You can modify your code before this is running. If it starts running, it will run whatever you want, but then whatever modifications you do after it's running, it will not take place into the code because it's running the old version. Okay? Fine. Okay. So more exercises, because I'm not happy with the exercise that I made you do now. Please try this one. This is more comprehensive. So if you saw with SLOC, you didn't get into the computed node. You were still in the login node. It just gave you the partition. This is the sequence of steps that you have to do now to get inside of a SLOC job, okay? So start with 1 or 2, ask again for the partition, get your job ID, and then do srun -- job, that number, overlap, --pty, --bash, okay? This is the way you will actually ask for a partition, and then you get inside of the compute node, okay? So go ahead, work on this one. Because I put there stars because I don't know what number you're going to get. You just have to change those stars. Yeah, what you have to modify is basically command number 4. So yeah, this is why I put there like get your ID number with SQ minus your user. You will see there the number, and then you write that number instead of the asterisk there. Okay? Write salloc for 10 minutes. The partition is batch. Then you execute SQ minus your username. So you will get only your jobs. Then you get that number of that salloc that is running, and you do srun dash dash job ID, I don't know, a trillion, and then dash dash overlap, pty slash bash slash dash minus L. Okay, all good? For those of you that have quicker hands, you can go to the second part, just pure run. Good? Yes, because slog, technically speaking, is just telling Slurm, give me a partition, give me these resources. But you're not jumping into the resource, you're still in the login node. So then you said like, okay, with this run, I want to get inside of the computer node. The computing node, then you will see the change in your user. You will be user at something. When you do the srun. Because slog is just telling like, hey, I want to participate to Slurm. And then when you execute srun, you get inside of that job. Yes. Yes, that's did you ask for a GPU? That's a very good question. Now, for example, now that you bring that up, it's like when you get into the glogin node, many people think that we have GPUs available there. That's not the case. The GPUs are offline in the login node. So when you ask with srun for a GPU, that you do dash dash GPU equals 1, then it will give you a GPU. And you will see it because it's your name at GPU some number. Then you can do NVIDIA SMI there. And if it's not working, maybe you need to load the CUDA module to invoke the NVIDIA SMI, which will be weird because usually you just get inside of the node and NVIDIA SMI is there. But the trick here is like I've been specifically asking for CPUs so far. There is no command there with GPU in this slide specifically. Okay, were you able to go to the second part, srun? Yes, question. Yes, your assessment is correct. When you use SLOC, it was just asking for resources, but you're not jumping into the computing node. So srun will actually allow you to jump into the computing node. When you run specifically srun, it's asking directly like, I want to be in a computing node for this amount of time. Now, if you follow the complete exercise, when you get to SQ, that's just me, which is a very nice way to see your jobs. You will see that SLOC is still running, but srun is not running. You have in your list the SLOC running because it's not dying in the moment you get out. srun, that's the big difference. It dies when you get out. The job stops completely. So any information that you generate in the memory, it will be gone. SLOC on the other side is continuously there. Okay? So that was her assessment, like what happens, why SLOC is there. And when I ask with SLOC, I'm still in the login node. That's the reason, because it's still running on the background. You just have to know how to jump in with srun. Continuous, yes. Yes, yes, exactly. srun finished right now. SLOC continues. Yes. It continues to run, yes. Uh-huh. Yeah, SLOC, it will be just for resources. You can run things inside. I'm not sure about that one. If you run something inside, it will continuously run. Because usually when you want something to run for a long time, then you do batch mode. Yeah, you do the next that we're going to see. Okay. Everybody was okay with this little exercise? Okay. Shall I continue? Yes. All right. So the next part, exactly that, sbatch. So, like I told you, sbatch is more like a small letter to the Slurm manager that will allow you to put more details. This is more ordered because it's actually longer. You can put the same kind of things that you see here, highlighted in the square, in one line of srun. But it will take you like half of your line or more, and then you run out of screen, and then it becomes really, really difficult to know where to put what. So the sbatch, as you can see here, will allow you to do the exact same things, but in a different manner and order. I like it better because it allows me more control. So in this case, you highlight in your script hash sbatch dash job name, blah, 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 blah. And you can see here, we're actually asking for 1 GPU and just for 5 minutes, okay? That's the head, usually, of the script. It has to have these sbatch directions. It could be in any order, but it has to be kind of in the range of the resources that Ibex has. It's like you cannot ask for 500 GPUs if we don't have 500 GPUs, right? But that's part of the trick. So in this case, as you can see in the second part of the script, then is when you set up your computer environment. That's when you do the loading of the modules or your own loading, saying like you have a conda environment or you're running a container or whatever you need to work, it should be the next step. Okay, in this case, we are actually loading the GPU stack that I mentioned you, just to be sure that you're going to get all the programs that need GPU. And then you're loading the machine learning module, which has TensorFlow, PyTorch, and so on and so forth. And you can deploy it with Code Server, or you can deploy it with Jupyter Lab. And after that, then comes the fun part. Oh, something happened. Okay, in the last part, you can see that then you can put your script to run. Okay? So that's basically the 3 parts of the script. And basically, we have pretty much all the things for you already prepared. So this one will take you a little bit more time, but this is exercise 3. So for those of you who don't have a /user, go to the scratch and then do this command, git clone http gpu github -cas data science onboarding.git. Okay? Then go into data science, cd data science onboarding JavaScript -template. And then you will submit your first job using SBatch, which is basic Slurm. Okay? Go ahead. Take your time. If you didn't have the /user partition, if you have Scratch, that's the only change. A couple of you have only Scratch. So instead of cd ibex /user, is ibex /scratch user. Okay, so far so good? Yes. What should... Oh, okay. So I see. Virtual environments. So the question was, what do I do if I had the need for something that Ibex doesn't have installed as a software? So you have 3 ways to do this. The brave way is like you learn how to use containers. You install whatever you want for whatever you need, and then you run it on Ibex. That's one. That's the brave one, because it takes you time to learn what is a container, how to build it, and so on and so forth. It's not that, once you get a hand of it, it's not that difficult. Yeah, you can run containers on Ibex. You will see how in the last part of this workshop. As a matter of fact, the good news is that we have 2 ways of running containers on Ibex. The second part, which is the utilitarian part, you know what I try to mean. The most useful way is you install Miniconda on Ibex with our instructions of how to install it, and then you run Conda. You create your Conda environment with whatever you want, with pip install, with whatever you want, right now there in Ibex, and you just load your Conda environment. We have examples of that too in this repo. And actually, we have in our YouTube channel, like and subscribe, examples of how to use Conda. But that sometimes creates some problems, but usually I have like 14 different Conda environments in my Ibex profile. And it's like, I just run them, I just load them, and that's it. End of the problem. The problem might be later if you want somebody else to use the same. And you have to export the correct way the Conda environment. Now, the third option, which is those are not brave enough, or at least they don't want to think about it too much, you can write a ticket to ibex.hpc, blah, 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 the one that I showed you in the beginning, and ask like, please, sysadmin, can you install this on Ibex as a module? It will take you more time than to try to install your Conda environment or create a container. But my colleagues, the sysadmin, will do it. When? I don't know, depending on how much work they have. So it depends on you. How fast do you want to work? If you're fine with waiting, it could be a module. But also, if you want it to be a module, you better justify that it's not just you using it, it's you and your group using it. All right? So, like I said, the brave wave, the useful way, and the third wave is when you don't know what to do. Because, to be fair, also sometimes things doesn't compile in Ibex. So it becomes different for each case, but you have all that. Okay, so everybody was able to do the S-batch Slurm? Yes? Okay, so with SQ, you should be already seeing that it run, or maybe it just finished, because it's a super simple thing. Right? If you do ls minus ltr, do you see the files that it generated? Yes. Uh-huh. Ah, yeah. If you need guidance or whatever, come and talk to us. And I will tell you first, like, go to our YouTube channel, click and subscribe. But sure, it's like if you have questions and it's like I want to install this software myself, for sure I can help you. My friends can help, my colleagues can help you with that. And it obviously, like I said, it depends on case to case. The usual, like the useful way is you create your code environment. But the most advanced and kind of secure way sometimes is the container, because that is still going to be forever and ever like that, and you can just run it. So it depends, but if you want to learn how, we can tell you where is the material or when to come to another of these beautiful workshops. So if you ran your first basic Slurm, congratulations. That was it. So if you want, we can take a break of 10 minutes. You seem decaffeinated, so we're going to take that break, okay? So hydrate, get some cookies, and we will be back in 10 minutes, okay? Okay, so when you're a data scientist, you usually have to do a lot of software development. And one of the things that you might need is an interactive development environment, also known as Jupyter Lab, VS Code, or RStudio. And you will find that it's very easy to work in any of those three in your computers. But how do you work with these kind of things inside Ibex? That's actually a very good question, Didier. So we have different explanations. For those of you that are really beginners, I like you to remember this slide. So an IDE, an integrated development computer, is a program in the computer that will allow you to do more computer programs. But the very good part about it is that they have usually more tools to do it, and it's more relatable. It's easy to use. It has text editor, version control, compilers, interpreters, and so on and so forth. When I was young, I didn't have this. But when I was doing my PhD, then Jupyter notebooks appear in the scene. And the Jupyter notebooks were a big step forward into just learning how to do scripting and things. So now we have something that's called Jupyter Lab that looks like that. That's the thing you see there. And it has, windows to have your own terminal. You have your data or different folders. So it's easy to use and very, very intuitive. It's normal to have it. So in this case, I will be with you in this exercise because it's very difficult to actually pull it off. As you can see, it's 10 different steps. So let me just explain. You're going to be in the same data science folder. Then you're going to try to do this sbatch, just like that, okay? Then you wait for the actual error file that is there. And then you read the instructions. And in a second terminal that you will need, you will paste those instructions. And then you type your password because it will actually prompt you to say like who you are and what's your password to enter Ibex, okay? And then you go back again to the demo, and then you copy the information, and then you paste it into a web browser. I see your faces, and I know it's very, very long. It doesn't explain really, really well what's going to happen. So let me demo, okay? Bear with me a second. Okay, that's good enough. So here we have our web browser. I will put it like this for the moment. I have 2 terminals. Is this font enough for you? Okay. So by the way, every time you log in into Ibex, you see this nice thingy here. This is your daily message. Sometimes the system admin comes and put some announcement there like, hey, we have problems. Hopefully you never see that because this is what you want to see. Ibex is fully operational. Okay? If you have any issues, you know who you call, not the Ghostbusters. But okay, I'm in my login node, okay? So I will go cd/ibex user my name, then. So you have something similar. You're already here. If you are lost, do print working directory. And if you are really lost, who am I? Who am I? There you go. I found myself. So in this case, we're going to do the following. sbatch launch Jupyter server. For those of you that are not used to Linux, when you do tap, it autocompletes. Okay, so it's very fast to work. If you find yourself that it just autocompletes to a certain point, you can do double tap and it will deploy all the files that is in that particular folder. You see here that I have different examples, like how to launch Jupyter server with a conda environment. If you're using Shaheen 3, there is an example here too. We're going to use this one here, okay? So Jupyter server.sbatch, and literally somebody, one of your colleagues right now was asking me, like, is there any difference between naming .sbatch your script or .slarm? There is no difference. The only part that matters is that you do sbatch, okay? So you click enter, you submitted a job. Nice. SQ minus me gives me that it's running, okay? So if I want to see inside of this folder, again, dash launch Jupyter server batch, you can see the whole script with that, okay? We just ask for one GPU with 16 gigabytes of memory in a partition with a job name demo. You can see the demo name here. I will receive an email if the job is running or it failed or it terminated. And then it will write an output, whatever happens, or an error of whatever happens, okay? I'm loading the GPU stack just in case I forgot that I'm not in the GPU login node. I'm loading the machine learning module, and then there is a bunch of different directions here. So let me clear this. Okay, fine. So ls minus ltr. You can see that I run this several times, but I want demo. This specific demo here. I will control copy that, control A to go to the beginning, and just cut this. So you see there is a bunch of things here, but what I want you to see is what is at the beginning. It's telling me that we loaded the GPU stack, is loading CUDA, is loading the machine learning module, and then it's telling me this GPU is listening to this port. So I have to copy this SSH command here, okay? I copy that command, I paste it in a new terminal, and this will create the bridge between Ibex and my computer, okay? That's this SSH4. Once I do this, you can see that I'm again inside of the login node on Ibex. I can go all the way down here, and then I can either copy one of these. I will copy this one because it's the one I trust. I go to my web browser, and I copy it here. And then wait, patiently wait, and there you go. So now I am inside of a Jupyter notebook, okay? Jupyter Lab itself. And I am looking at all the different files that this repository had. The cheat sheets, the binaries, the containers, how to install Miniconda, how to launch different things, even notebooks here. Okay, very easy to actually navigate. This is more friendly to you, right? So for example, we can go to Introduction to Linear Algebra and Hyperparameterization. And I can actually start reading this, resolving this by running just this cell. Okay? And then you just start working. You can create a new one, right? You can go here into the launcher, and you can say like, hey, a new notebook. It creates a new notebook. You don't want to see this, you click here. You want your terminal to be in another part, you drag it here. As a matter of fact, let's blow this up. You can see where you are, brain working directory. You can see all your files. There you go. Okay? Now, this is how you can start working with Ibex. Let's say that you have to run something. Oh, it doesn't look very well. But you want to monitor the GPU utilization. You can paste it here. There you have your memory, your machine resources. Why not? Because you're very curious. And so on and so forth. Okay? You can do this very easily. This is already inside Ibex. So if you see here, you're already in a compute node. So you have that compute node for you and your workflow. Okay? So I want you to do exactly what I did. And tell me if you can actually manage to deploy it. Okay? Once you're done with this, you go here and you shut down. Okay? Stop. You can close it. All right? And then you will see that this is actually complaining. Control C to eliminate that. Exit to get out. And here in the login node, if you do the cat demo again, you will see that it shut down completely. Okay? No, you go to the top to file and then all the way down, shut down. So if you do SQ, that's just me, you should not find anything. So once again, I know there are different, it's difficult to go the first time, but these are the steps. Please try to do it and let me know your problems. Yes, question. Okay, that's a very quirky thing. I mean, we are redirecting the thing to the, actually, if you see the script, we're redirecting to the error file, the output. Now, it depends on the configuration. All these things that are like a log for the Jupyter Notebook are automatically directed to the error file. It's a preference. You can change it, but it's like, if you're interested in how the Jupyter Notebook works or you want to improve it, maybe it's information that is worth to have. The real part here is that you should not erase that information at the end of the day. But depends. It really depends. Okay. Yes. Another question? Yes, there is a way. As a matter of fact, it's the most beautiful way because it's with containers and it's straightforward. As I don't remember if I include that exercise, but I can show you. Let me clear this. Let's clear this too. Oh no, you can have multiple. You can have several jobs running concurrently. It doesn't matter, but let me go to containers. Let me show you in containers. Launch GUIs. We have RStudio. Where are you? Singularity launch RStudio. So, let me get back at this and do this like that. Okay. This is the script. And the only thing that you have to do is basically the same thing. Sbatch this script. This script will run in CPUs. It will generate the same things, like the name will be RStudio. You will receive an email. There will be an out, an error. And then it will take something called Singularity that I will talk in a minute. All the CPU stack. It will pull a container. that we did for you, well, the KSL did, then it will sort out all the different things. And at the end of all of it, you have how we're running the whole server. But you have also the same thing, like some instructions here. Like you have to take, again, an SSH command. And then after you do the bridge between Ibex and your computer, you can copy this line here, localhost. Okay, that's for the particular case of RStudio. Okay. So where are you in this? Were you able to deploy the Jupyter Lab? Yes? Step 6. Okay, we can. Anyone else in step 6? Same, step 6. You're waiting. Or you're trying to connect your computer to it. Okay. You did it already. I know that. Yes. Uh-huh. Ah, yeah. So, uh-huh. Yes. Okay. So, two questions were asked. One, should I modify this when I need more time? Absolutely. Since I imagine you're not going to work 48 hours straight, I would recommend to change these for the GUIs to, I don't know, 8 hours. So, if you're working coding for 8 hours, you're my hero. The other question was like, okay, I launched this, but it's taking too long to give me back the things. The game here is patience. Okay? Remember, you're sharing this with thousands of people, actually 1,000 people maybe. We have like more than 1,000 users for Ibex. All right? So the name of the game becomes patience. Like if I do the same, I will have it run it in no time, maybe. Okay, mine entered really fast, but it's the same idea. Yeah. Yeah, errors are usually quick. Let's see if mine is already done something. No, it's downloading. You see? So again, name of the game is patience. You have to give enough time to set up stuff. Okay, moving on. If you find this difficult, you're going to hate me in the next one. So what is Code Server? As a matter of fact, what is VS Code? VS Code is the most popular IDE from Microsoft. Now, they will tell you it's the most popular IDE in the world because they're Microsoft. But truth be told, it's very easy to use. It's highly customizable, very flexible. It's not only for Python. You can basically code in whatever you want. And they were the first ones to actually implement that AI coding assistant thingy. Now that's everywhere. To my knowledge, they were the first one to actually make an app out of it called GitHub Copilot, which, by the way, raise your hand if you have it. One. GitHub Copilot. No, just one. Wow, that's a new. So I'm asking you because it's free for you. Now, it's free for everyone, apparently. But before it was free for everyone, apparently, you have preference of usage because you are students in the university. So if you have an account on GitHub with your current university email, there is a section in GitHub where you can enable it, and it's free for you. You don't have to pay for it. Otherwise, you can pay for the pro, but you will have access to the pro version because you're students in a university. Okay? So that's something that I find strange that nobody knows, but at the end of the day, they were the first one to implement. Fine. The real power of this is that it has several apps, or what they call it extensions, which are ways of customizing depending on your task, how it looks like, how it works. Sometimes it highlights stuff. I mean, if you're bored, they have even virtual pets for you. I'm not kidding. So in this moment, we're going to try to do the same thing. It's the same steps as before, but now with the code server script. Okay? Once again, I'm going to sit down here and let me join. Okay. Which, by the way, if you want the slides, it's on the website. Yeah. So I will update the version of the presentation after this workshop. So, yeah. So I was going to do this. Let's clear this. Let's batch. So launch code server. Launch code server dash Ibex. So there you go. SQ dash me. Okay. You can see, for example, I have RStudio running here. I have code server running here. This is going to a compute node with CPUs. This is going to a GPU node. Okay. This status here, don't be panicked about it. If it's R, it's running. If it's CF, it's just changing the resources towards you. So don't panic if also here says something like node not available. Sometimes you just have to wait. Okay. Now we have here the error file. There you go. So you can see here the same thing about the SSH bridging my computer to Ibex. Okay. And now I can copy this into my web browser. Where is my web browser? There you go. So if I put this longer, no, not here. If you can see here, I have localhost this, blah, 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 equals Ibex user, my user, data science onboarding. It will prompt you to something that is a very useful question, like, do you trust yourself? Probably you shouldn't. But yes, I trust myself. Now, here you can change to different, colors, whatever you want, right? So I'm going to keep that. So Here you have, for example, something that is version control. This is Git. And here are the extensions. Give it a moment, it will load. And then you can install whatever you want. As a matter of fact, I want to install something called continue. There you go. This guy. I want to install this guy. So once I install this guy, it's going to tell me like, okay, we're ready. You can install things for C++, for Java, for Python, whatever. Okay, this guy is ready. Now I have it as an app here. Now I want to do something cool with it. Like, I want to run Olama. Okay, I want to run this thing here. I will then get wait, where is my terminal? Out. Okay, you out. That's all. It should be deploying something. Okay. Terminal. Okay. For example, this one is already allowing me to use Olama. Like, who are you? But of course, I need to put my IP address. Okay. This script is here in code server. Launch code server, continue. But, you know, it's just to see it there. Where is the terminal here? That used to be the case that it was over here. There you are. Let's put this over here. All right. But at the end, it's the same story. Can you please try to run it like that? Okay, it's just another way to deploy, but every time you deploy this, it will be the same story. This is the safe way to do it. Yes. Yes. As a matter of fact, yeah, I mean, about that, you mean this, right? This is VS Code. So you have you already installed this app, the remote extension, Remote Explorer? With Remote Explorer, you literally go to VS Code. You can open this here. I already have configured that, but it's going to ask me for my password. Now, the difference is here, you're accessing a login node. You're not accessing the GPU. Okay? You will be working in the login node. I am already there, still opening. Okay. It's taking its time, but at the end, it will deploy stuff here. Okay. You were not here. There is a special login node for VS Code. It's in the first part of the talk. So you connect to with your local VS Code, you connect to that login node. but you're in the login node. You're not in a compute node. So what we have been deploying right now is inside of a compute node, inside of a GPU, meaning that you can deploy whatever you want there. Do not work in the login node. That's the difference here. The trick here, when this actually connects one more time, at some point, what I advise is to actually work in the terminal. Finally, there you go. So there is all the files there. But here, let's put this aside. So here you're in a login node, and it will give you some CPUs, but this is not what you want. As a matter of fact, what you want is srun. No, with VS Code, you have this remote Explorer extension. Use that to connect to anywhere you want. This is, for example, my workstation. This is another mini cluster. This is VS Code. This is Ibex. And then it will do everything for you, but you will be in a login node. And then what you have to do is to do srun in your terminal, and you could have then a GPU for you. And you can run your scripts there. But as long as you don't do that, you are in the login node. So if you want to work with VS Code inside of a compute node, then you do this exercise. These steps here will automatically give you the resource, and you will be inside of the compute node. You don't have to worry about anything else. Yes, this is in the browser. That's the difference. This is the browser. Also, the Jupyter Lab is using the browser. RStudio, it will use the browser too. Okay. Are you suffering enough, or should we just stop? Everybody is okay? Yeah, everybody deployed? Yes. Okay, shall we move on? Everybody okay with that? Yes, you have all functionalities inside of the GPU. So, I mean, virtually there is no difference between the VS Code that we are using for the web browser to the local one that you have. It's the same amount of the same amount of applications, the same functionality. The field is the same. I mean, it's a clone. So yeah. By the way, what happened with my... Now, if I come back here and I do sq-me, I still have these things running. Let me see if RStudio is done. Complaining about something that's important to note later. Okay, for RStudio, I have the same story. Copy the SSH. My password. And then I just copy this direction here into my web browser. And I have now full functional RStudio. So for those of you that like statistics, RStudio is pretty neat. I actually love RStudio because it was the first IDE that was actually gentle with you when you were learning. But that's the thing. You can use all these three if you want. If you don't, choose whatever you want. I mean, VS Code also can run R if you're interested in that. Okay. Now, good. Let me remove all R and all out. This should be enough to clean a lot of my space. There you go. And now I want to cancel all my jobs. So I do scancel -u user. And that should cancel everything that is under my name. Then it's complaining because it just ended. And then I type exit and type exit. And I'm back in my computer. All right. Go down and go down. Okay, how are you feeling? This is almost the last part. Okay? Containers. So why containers? Well, there are two things that I should ask you. Is your research reproducible? Hold your attention. Raise your hand if your research is not reproducible. No? You all can reproduce all your work. Right? Should be. I die. So, how do you reproduce somebody else's work? Not your work. Like, tell me, what do you do when you want to reproduce Einstein's work? Well, not Einstein. Let's go back to hundreds of years. What do you do when you want to reproduce Newton's work? Like, we have a very, if I told you force equals mass times acceleration, what I'm telling you? Just the equation of force, right? Gravity. So, oh, I didn't do the switch. There you go. So, I am telling you this. Why? Because you might have heard that reproducibility in science is important for some reason, right? Usually you want that your job is able to be reproduced by anybody else a long time later. And in theory, that's the ethos that your labs have. But how do computer science can do this? It can be done in different ways. One of the ways is doing a virtual environment, like the Conda environments. When I was younger, I used something called virtual machines. And then somebody come and told me about containers. So let's start by the very beginning. What you have there in your desk is called bare metal, meaning that you can install things in your machines and it will run inside your machine with whatever it has, with probably very specific libraries that runs on you. You have seen this probably when Apple had the idea of having his own silicon, the M1 chips and so on and so forth. It broke a lot of the different pipelines because it was not Intel anymore. And Intel was a different architecture, blah, 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 blah. So in a nutshell, how do you do that the same program gives you the same response, the same answer in one Mac machine and in a Windows machine, in a Linux machine? If you have different computer components inside, it can change. And in some science, like like small changes make a difference very big. So one of the things that people started to do was virtualization. The virtualization, what is? Basically an complete operating system with all the apps taking the energy, the electricity from your computer. So in my time, if I wanted to run in my Windows machine a Linux machine, basically I have to install it. It will be as slow as a snail, but it will have all the things from Linux. Let's say Ubuntu or Kali or whatever you want to install. But it was going to be super slow because then you have two OS sharing the same resource and basically killing your battery. So the next step, it was like, hey, let's not do virtual machines. Let's do containers. But what is a container? A container literally sits on top of your OS, and it's just telling you, hey, I have these things here. Just let me run it, and then I will be done. And can be very lightweight, so you can have different containers running at the same time. Okay? So the question was already asked, like, how do I do an installation if all my dependencies are different and I'm just the only user that is going to use it in my lab or for my research? So one of those things is actually do a container. It's good for sharing and collaboration because then you have something that is frozen in time that you can pass on to your students or to the sons of your students or the grandsons of your students, and it should run the same way it runs for you. Okay? That's the container philosophy. It will be something that is frozen in time. This is important. Why? Because there are some other ways that people can lose packages. When I had hair, there was a thing called BLAST. And BLAST is a program that has been forever and ever written and maintained by the NCBI in the United States. It's a very well-known, usable bioinformatics tool, but it has had so many versions, some of them are gone. Nobody has the binary for it anymore. And if your PI is telling you, please reproduce this from 40 years ago, you probably are not going to find the binary. Okay? But if it's in a container, then you can run it as like somebody who lived 40 years ago. Okay, I'm probably exaggerating, but you get the point. So we have two things in Ibex that can run containers. So the first one is Singularity, and the second one is Podman. These two platforms are for containers. The most trusted for HPC, meaning for clusters like Ibex, is Singularity. And the other one, Podman, is more recent. But Podman looks a lot like something called Docker, which is the popular container platform run around the world. So if you know Docker, you know Podman by default. Singularity has a special syntax, a special way to write it. But it's not impossible to learn, and it's really, as a matter of fact, it's really easy because it's basically pull from Docker whatever you want, convert it into a Singularity file, and run it as a container. That's very broad how it works because it has details, but we're going to do something like that. So in this exercise, we're going to use something called Horobot, and we're going to use a GPU. So what I want you to do now is to enter the containers folder. If you want, you can modify the single node horobot srun.slurm. What you need to do, what you really need to do, is to copy Horobot GPU from that direction over there. Okay? And then submit the job. Submit that single node Horobot run. All right? That's the exercise. So go inside of containers, copy that horobot.gpu seed, GPU 0192 from that direction, and you can submit the job. So I see you're confused. And I can tell you how to do it. Yes. Really? Let me change that. Ibex temp, KVL, and AI, portable. Okay. Control copy. Okay. Permission fixed, I should say. So you go inside, put this down. Containers. Okay. Copy this image here. Okay. I already had it there, so it's cheating, I know. I have several here, as a matter of fact. Here is single node Horobot. If we see what's inside of single node Horobot, okay, whoop, a little bit more. So it's asking for 10 minutes of time. One node is going to do 4 different activities using basically 4 GPUs. The constraint here is that we're going to use a coveted resource that is the B100 GPUs. And the job name is going to be Horobot demo. What this is going to do is to execute PyTorch, and then it's going to execute TensorFlow. This part maybe is not going to work because Horobot and TensorFlow doesn't get along that good so far in my experience. So once you see this, what we are going to see is that there is a PyTorch one node log, and we can follow it along. It's going to execute this in a parallel way in 4 GPUs, but one node only. And it's going to do something classic called ResNet, which is a very, very normal thing, well, very useful benchmark that exists out there. So there is batch, single node Horobot. Okay, mine is working. If I do SQ, I see some of you are already working. It's me and 3 persons more. So, in fact, here I have this PyTorch. Okay, so it's running. Okay, I do tail minus F, so it's interactive. What is happening? Yeah, so what is happening technically is that each GPU is loading a number of images. ResNet has about 70,000 different images that is loading into the memory of the GPU. And then basically it's training a neural network there. Okay, this is what you're actually running. And now it's done. So that's the whole training of a ResNet neural network with around 70,000, 60,000 different images. Okay, Control C to exit. And there you go. So if you reach this stage, congratulations, you run your first deep learning algorithm in Ibex. So let's see. Okay. Let's see if TensorFlow is actually running. Ah, yeah, it's running. There you go. You you have empty files. Is it running? No, no, no. When you do SQ, that's just me. That's why. And it's done. When you submit the job. Uh-huh. Uh-huh. Yeah, it's done, right? Nothing in the log. Interesting. Give it a time. Sometimes it takes a little bit time to write. Yes. Now, this one in specific was NPR because we want the parallel power. Okay? As a matter of fact, the next exercise has nothing to do with AI, but it's a comprehensive example of how to use SRun. Okay? So take, for example, this exercise will run only a very easy commands, hello world and Alpine. Alpine is a Linux distribution that is super small. It has only the essential things. So it shouldn't take you that long. Okay? So please go ahead, try this exercise. As a matter of fact, it should run for less than 30 minutes if you want. But as you can see, you use srun, you will jump inside of the GPU at the moment. Okay? Then you have to create these directories. It has to be Ibex user podman and run user the boss. That one that is in red is going to live for as long as your job is on. Once you're out, it will die. Okay? Then you will run hello world for podman. You will do this. Now for podman is interesting because you have to add this root command that is in blue. That one will redirect podman to your space. Otherwise, it will tell you that it cannot do anything because it will try to access the whole Ibex. So podman dash just root, it's necessary to point to where you want to work. All right, and then you do run dash dash remove hello world. Okay, try it. So another thing, we're asking for one GPU because Postman is installed only in the GPU nodes. So another comment about Podman, you can actually install it in your computer. There is such thing as Podman Desktop, and you can technically do the same thing as Docker, but with this tool called Podman. So were you able to run Hello World? You still in step number 3, maybe? By the way, just remember you have in the lateral you have big screens if you cannot see clearly my writing. All right. So if you were able to run Hello World, you should see the same icon as Podman, like 3 heads of a. It's not a seal. It's something different. I don't remember what's the name of that animal, but it's not a seal. You will have like hello and then this logo with ASCII. If you do the next one, pull an image, you will pull something called Alpine. It will be super quick because it's super small. So in the first line, you're running a container. In the second line, you're actually acquiring a container. And then in the third line, Podman images, there should be a list of images that you have now on your directory. And that's another way of how to run containers. Yes. Make dir minus p. So minus p means watch for the parent, meaning that if you already did these folders, don't do it again because I found them. That's the minus p meaning. So it's make a directory. If you don't find them, create them. But if you find them, do nothing. Yes. With Podman. If you well, I just said Podman cannot build stuff. Podman can pull Docker things. But Podman can build in your computer the Docker file. So what we recommend is like you install Docker in your computer, push the Docker image to the Docker hub, and then you pull it with Singularity or Podman. So the building, actually, the only Singularity can build an image inside Ibex. I have an example there in the container folder. There is the example of how to build a Singularity from the Docker image in the Git Docker hub. Yeah, no, don't worry. Why is that complex? Absolutely excellent question. I do not know. I am not system administrator or developer for Singularity and Podman. It is complicated, yes, I know. But if not, it wouldn't be called research. Anyway, truth be told, could be simpler if Docker fixed problems with the security they have. This is why Singularity and Docker exist, as a matter of fact, to run in the HPC clusters. What you want in an HPC is that everybody is contained and no data leaks out, and more importantly, nobody takes advantage of that to get in and mine Bitcoin. But yes, it sounds complicated, but it depends on the flavor that you're going to choose. Why no one can connect to your? Yeah, because in theory, you should not allow anyone to enter your account in the HPC cluster. That's a security breach. How is what works? Like, yeah, no one can access either your files, your info, or your data. And it depends. We have here in the university people that signs NDAs to not share the data. I mean, it's part of the culture of every industry to have property intellectual property. So that's one. The second one is like, we don't know when there is a breach in the security that then somebody can get access to the HPC cluster and do something malicious. Like, for example, in the clusters, we do not mine Bitcoin and we do not design weapons. So it's about that kind of security. Now, if we had something more stable that we allow you to use directly something, and we are managing that security, and we do not allow anybody else to use yours, that's okay. But if you share then your endpoint or whatever, that might be a problem. Yeah, absolutely. But that's on the user side. If you allow somebody to connect to your endpoint, that's on you, not on us. But I understand where you're coming from because, for example, AWS allows everybody to connect, right? Amazon Web Services is basically that. Yeah, it's complicated, I know. But we need a bigger team to manage it like that. Yes. Uh-huh. Okay. Ha! Okay. That's curious. Cannot find it. Well, we will have to take a look at your user. Okay, so far, everybody pretty much run into problems with this or try to run it. So? Hello World, were you able to run Hello World? With running Hello World, literally the icon of Podman, and that's it. With Alpine, you should see nothing, just like allowing you to download something. Yeah, I mean, it's just for you to know that this actually is in the cluster. Okay. Okay. So, last part, but not least, I know you're tired. This is the last part, and this is more related to deep learning, aka now AI. But this is called scale demos for a reason. You ran now a Horobot for one node, and you already have 4 GPUs, right? So when you try to train big models like ChatGPT, you need like a gazillion number of CPUs, right? Imagine that OpenAI had only 1 GPU to do the whole thing of training an LLM. There is no time in the universe to actually fine-tune that kind of model, right? So when more is better mean that sometimes you have that type of problem that the more resources you ask, the faster you end up with an answer. Like, say, for example, you have to basically punch through 1 million files, and you have to analyze each file. So you can do one script that runs in 1 CPU and analyze 1 file. You just need to run it in 1 million ways, in 1 million CPUs, and you will have in 1 minute the answer for all of that. I know, I'm exaggerating. Sorry, I'm dramatic. Latin America. So the point is that if you have this kind of problem, you just need to put or ask for more resources. Maybe it take you 24 hours, but then you will crunch over 10 million files. And then you will just to analyze with one final collate Python script or R script. The point is, like, you want to work fast, right? So the more resources you ask, the faster you go. This is why we have HPC clusters. That's the idea. Part of the idea, I should say. So this is the kind of thing that people in deep learning call scaling. When you have to run your neural network training and you have one GPU, it could take you 10 hours. But then if you have 4 nodes with 32 GPUs, then you don't stand, you just train the whole thing in less than 1 hour. So you can work faster, right? The only problem is like who has 32 GPUs? Well, you now with Ibex, you have access to maybe that many. And for just the small amount of 1 hour, yeah, sure, have it, right? But that's the point. Do you prefer to be 10 hours waiting or just 1 hour? Also, it depends on you. Maybe you're on vacation, I don't know. That's the point here. So I'm going to tell you about 2 frameworks that we have that I know that works in Ibex. One is called PyTorch DDP, and the other one is called Horobot. You already been introduced to Horobot. It can run TensorFlow, and it can run PyTorch. With minimal changes, then you can start training or getting the benefits of having several GPUs running through your data, okay? Now, don't be deceived about this. It's like, well, PyTorch DDP is kind of slower than Horobot. Yeah, but you can have everything running PyTorch, and that's fine. If you're fine with the scale of time, that's fine. And 16 GPUs, okay, 2 hours, not a problem. You go, you take a meal, you come back, your training is done. Okay, that's the point. Like, don't be just deceived by this plot. Yes, it can be very easy to just run everything in Horobot. Absolutely, go for it if you want. So in this exercise, you're going to be in the container folder. You already have Horobot GPU 109 there. Okay, so just run that. Do sbatch. Again, there should be a log file that you can basically watch. And then you have been now running the same training, but in multiple GPUs, sorry. All right, pretty much as the second to last exercise. Just submit the multi-node Horobot. See if it fails, because for me it failed just yesterday. Yes. Exactly. I didn't say it, but silencing means just comment it out. So let's go back here. Maybe it should look something like this. If you put this hash in front of it, it will be stop. So let me tell you about this. To start with, we're asking not for one node, but 2 nodes to run 4 tasks. That means 2 GPUs with this minimum of memory. We're again asking for B100s. It's very, very, very fast, only 10 minutes. What you see here now is different to the 1 node because we are specifying number of processes in parallel 4, but number of nodes 2. And then you execute with singularity the image that we have, that Horobot GPU, and then is running PyTorch synthetic Pi, okay? That is already living there, which is a very nice example from our friends from PyTorch. And you see here, for example, Horobot, there are lines. So if you have actually a curiosity or need for this, come to talk to us to know how to use Horobot. I mean, there are very few changes, but at the end we have this log that we see. Oh, this batch. Okay. It will be a little bit busy because you are already working on it. Mine is running. Okay. We have 3 customers if I take myself out. Static just started. I'm in the middle. Chen XD 0. Full name. Okay. So if we do the same thing, is running. So at the same rate, the thing here that makes it different is this is running in 2 nodes. Why would you need to run in 2 nodes your workload? Maybe because you need more memory. Or maybe you need to distribute the load of your neural network into different GPUs. That's part of the point. Sometimes you just need more memory. Sometimes it goes faster because it's working with different numbers of CPUs and GPUs. Okay, part of the tricks. But if you reach this part, congratulations, you run your second neural network on Ibex. Oh, exit. Oh, there you go. Okay. And for the last, we're going to use now PyTorch DDP. Now, why I'm telling you to use PyTorch a lot? Because it's very, very popular among developers. So for this one, it's very straightforward. Instead of the containers model, go and enter the PyTorch DDP model. I don't know why I put load the machine learning module, but because you have to download the data. So let's do that. And then you can run the multi-node, multi-GPU Slurm. And we will kind of see the newly created log file. Okay. So let's do that. Let's do cd dot cd PyTorch. Yeah. Where are you? Torch DDP. cd torch DDP. Okay. Then you do module load machine learning. With this, you do Python. Where's all my .py? Python, download data. It will start to download the data that you need to run this example. I cheated because I already have it. Okay, Python download.py. Fine. Now let's batch this one, multi-node, multi-GPU Slurm. And there you should see these kind of things. All right. And you should see some out here. It will start complaining, but then it will start training. There you go. So for those of you that do not know what an epoch means a run through the data, meaning that every time that the learning is happening, the data is pushed through the whole network and coming back. That's an epoch. And then the magic of deep learning happens, and it's adjusting everything inside. But you can see there, we have something called loss, meaning how accurate it should be according to the training, and it should go down and down and down and down. That's what you want to see. Now, this is a very classic example, so it will be successful. And in theory, you should see the same. So for me, it's almost done. There you go, finish training. And I have an accuracy of 28%. That's terrible. But the theory says that if I give more epochs, it will start to improve. But it will take me many more hours, which I don't want you to be expending here, because this is just a workshop of examples. If you want, you can run it for more time and see if you can end up with, I don't know, 99% accuracy. But take into account, you see that number, 10,000 test images? This is because we're training with 60,000 images across 2 nodes. So you can modify the example if you want, just to see what happens. But I'm actually very happy to have 28% for this example. So now that we reach this part here, okay, I will put some extras in the slides, because I want to mention this. That's something that everybody actually asked me. Sorry, give me a second. So we have talked about how great is Ibex and how good is the training and blah, 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 and how handsome I am. But we haven't talked about how do you copy stuff into Ibex or from Ibex. So this is one of the tricks. You have, for example, in the docs, if you go to data management, you have these commands here. So for under 10 GBs, you can use super copy or super FTP. That's fine. But what we recommend is to use rsync. Why? You will see one of the examples. So in this exercise, if you want to do it, if not, that's fine. This is the example that I want to make. So rsync and all those letters there can help you to copy from your computer to Ibex without losing the permissions and the configuration. It's very often that we copy stuff from our computer to Ibex, and then Ibex just write that is from somebody else in another place, in another work. And that generates problems with your quota of files. Remember that you have 200 gigabytes or 1.5 terabytes. Sometimes when you copy stuff, it goes bad, and it changes the names and the groups. rsync is going to prevent that. This specific rsync, okay? So this is how you actually use it. To copy from Ibex to your computer is rsync all those flags, your username, you use something called mover nodes, and then you tell it where you want to copy, okay? Could be in your home directory, in your computer, or wherever you want to put it. Or in the other way around. You see, it's like just path to your file. Let's say you have file.txt, and then you tell it like your username at mover nodes, the path where you want. Don't forget those 2 points. Okay, it's just telling like, okay, connect to Ibex through mover nodes and place it over there. All right, that's the trick. That's pretty much the important part. If you're nervous, if you're a very nervous person, you can use -- progress, and it will put a nice bar there, and then you can rest and have your OCD different in a different manner. All right. So I put some examples here, like for example, rsync -HP progress, my documents onto my local hard drive, and I can put also like things on Ibex using like ranked PDB, my user add mover Ibex, where I wanted to put, okay, with the name I want. All right, that's the pro way. That's how professionals do it. So I expect nothing from you but this. But there is another way. So did you know that you can mount Ibex file system in your computer? Meaning that your computer has the capability of talking to Ibex, and then you can just drag and drop stuff. I do not recommend this for things that are very heavy to copy. But if you're copying like a file of 1 megabyte, you can do it very easily. For example, for those of you that really feel that you need to be pro, you can use in Linux this. You can mount it using locations, then opening these directions, SMB or FTP, samba.ibex. This is the way you connect to it. It will ask you for your credentials and your username, your classic IT credentials. And then you will have access to your home directory or to your Scratch directory or your using directory. You will be able to see it as part of your file system as it is in your computer. Okay? This is for Linux, for example. The other way, if you have a Mac, because they're fancy, pretty much the same story. This is still Linux. You will be able to access everything. Even in your terminal, you will be have direct access to Ibex. Okay? That's the point. It will be kind of part of your computer now. Now, for Mac, pretty much the same story. So you can connect to a server. You can write the SMB Samba Ibex thing. It will ask for your credentials. And then you can select what you want to see from Ibex. Okay? And that will be part of your computer. Windows user, I hate you, but because your usual applications that connect to Ibex or to any remote server already have these implemented. You can see the files already. MobileXterm has this capability. So this is why I do not put this for Windows. Also, it's been like 20 years since I used Windows, like having a very long vaccine. Okay, so it depends. On Macs, you have, depending on you can have Weka user, or it could be Ibex Scratch. We saw that at the beginning, that who has Ibex. If you have Ibex/user/your user, go for Weka user. Or if you have a project, if you have been working with your team in some kind of project, you will find it probably in Ibex-projects. And the projects always start with C, some number, and then you have access to that. But that's pretty much the things that you can do with Ibex. So, which by the way, once you get a feeling of how to mount it, you can literally look at it from your computer and drag and drop small files, not that 10 gigabyte file. Okay, for those one, please use rsync and the mover nodes. Yes. if, as long as I know, well, as far as I know, rsync actually just will update those files that you modify. It will create a list of files, and those that are new will be added. Those that are modified will be modified, including a timestamp. But if you didn't touch them in 2 years, it will remain as a timestamp of 2 years ago. So we don't have a purge policy yet, but we're reaching that point because everything that is in the scratch is on Ibex for as long as nothing happened to Ibex. But remember, there is no backup. That's the price you pay. Now, the other thing that unfortunately happens when we don't have a purge policy on Ibex is that there are files in your groups that I bet have been there for years, like 5 to 10 years, without no one touching them. So there is no purge policy. There is quotas per group. So it depends. But it's on the user and the group to clean that space. Okay, so that's all from my part. If you want to go, you're free to go. Nobody's holding you a point blank gun. But if you're interested and you know, there's more workshops coming. So visit again our wiki page. There are training events there. You can subscribe to any of these events. We always put there the recording of these sessions and I'm going to upload these slides on that site, so everybody has it. I routinely do workshops like this. If you need some kind of workshop, you need to tell us. Like at least 10 people needs to be there for a workshop. But as you can see, there is this workshop for the data science. The next one I will do is Git and PyTorch basics. My colleague Abdul Rafur is going to do machine learning in Arabic. We also have the machine learning in English, but you can see it in our YouTube channel. Like and subscribe. And then there is another workshops that have been already done, but you can actually see the recordings from there in our YouTube channel. So with that, you're free to go. I'm glad that you stay here this long. So time to eat. And yeah, only 3 hours. Any more questions? Complaints? Technical problems? Okay, those ones are good to offline. This is why I actually slot 4 hours. Okay, everybody happy? All right, size on. And I hope to see none of your tickets. Bye.